we will begin to make use of an important tool for the development of ecometrics called the BARI Geographical Infrastructure of Boston, Massachusetts. The geographical infrastructure is a multi-level database that compiles and connects the places and regions of Boston. It begins at the parcel level, which is the smallest ownable unit within the city. It aggregates these up to addresses, and then to intersections, street segments, census geographies, and then administrative regions. Each of these levels is a universe of all of the places that are known to exist within the city, or are the ways in which the city has been divided up. One can easily connect from one level to another, and therefore aggregate to try to create from, say, something occurring at a parcel or an address, measures at the tract level or at the administrative region. You will be able to access the geographical infrastructure through the Dataverse. And here we are inside of it, and as you can see, we have parcels, address, census blocks, roads, etc. For an example of how these are structured, let's go look at Census Tracts 2015. We see a description of the content, and as we scroll down, we see a series of files. We see a CSV, which is the type of file we've been working with most often this semester. We see an Excel version, and we also see a zip, or as we see underneath, a shapefile as a zip archive that we could use for mapping. Each of these formats is useful in its own right. In addition, the tract data is distinctive in that it comes equipped with a series of curated indicators of socioeconomic status, demographics, and housing characteristics accessed from the census. Last, returning to the higher level of the folder, and then scrolling down to the bottom, you will notice that there is a data set titled Documentation for the 2015 Geographical Infrastructure. This contains a PDF file that you can download that will give you complete information on the entire contents of the geographical infrastructure. Note that BARI updates its geographical infrastructure every year. As I noted before, a major advantage of the geographical infrastructure is that it enables you to flexibly build measures at a desired level of geography, whether you want to measure streets or neighborhoods or regional geographies based on its smaller components. A second advantage is the ability to isolate cases from regions with particular characteristics. This is best facilitated by the in command, which is written with percentage signs on each side of it. In is a logical operator that enables you to isolate elements that exist in another data frame or in another vector. Look at the two examples here. Take the first example. We see here that licenses is being subset to all those for whom co-zip occurs within the zip code column of another file that contains all the zip codes in the city of Boston. Co-zip is the zip code of contact for the owner of a business, and what this essentially does is identify all of the licenses whose owner is contactable at a zip code within Boston from those that are not, as an estimate of locality. This second example is a little bit more complicated, but also very useful. Assume that tax represents the tax assessor's database. Let's say we want to know where every assessed property is that is inside of a tract whose median income is below $50,000. For this, we use the in command to find tax $CTID10 that is within the tracts database CTID10 column, but for which tracts median income is less than $50,000. In this manner, we've used a second logical operator in order to isolate all of the places that fit a certain criterion, and then to identify all of the parcels that are within those areas.